Thanks everybody for joining the Troja AI webinar on securing AI model behavior. Just to get into the introductions today, I am Lee Weiner. I'm the host of this webinar. I'm the CEO of Troja AI. And James, you want to introduce yourself?
Sure. My name is James Stewart. I'm one of the founders here at Troja AI. I'm sort of on the technical and the data science side. I've actually built models in the cyberspace, and I only lay that preface because there we find ourselves always sort of bridging the gap between data science and cybersecurity, which are two separate and very deep disciplines all by themselves. So that's the gap we fill.
Yeah, and James spent time, as he said, as a data scientist, but also as a cybersecurity engineer, and previously had a startup focused on leveraging data science for safety purposes. Okay, great. Let's get into the agenda here. So today we're going to talk about Gen AI adoption and kind of the concerns we see around security that companies are having. The new and expanding Gen AI attack surface we'll get into, as well as the security needs around AI. And then we'll talk about how to protect AI models at build time and run time. But first, we want to have a little bit of a poll here. Okay, our first poll is, which Gen AI models are you using today? So we'll give people a few minutes here. We've got a good number of participants, and the results are coming in. The number one was commercial models like ChatGPT, 63%. And then it was kind of a tie between open source models and homegrown models. And then about 15% of you are still planning. I think, James, this is pretty much what we see when we talk to customers. There is a lot of open source adoption with things like Llama 2 and Llama 3 now. But the commercial models are fairly predominant, especially in enterprises, I would say. James, any comments on that?
It's interesting. If this were last year, the planning stat would be much, much higher.
Exactly. That is exactly correct. Yeah, which we'll get to that in a minute here, actually.
Not that there's anything wrong with still being planning.
Yeah, of course. Yeah. I mean, I think actually, James, if you look at what we were seeing a year ago in 2023, that's exactly what we were seeing. Is a lot of companies were looking at, what kind of Gen AI use cases they were interested in. There was some kind of AI center of excellence teams being formed around how to think about AI for the enterprise. Huge innovation opportunity, clearly. And then I think when we look at 2024, there's a lot more building, deploying, securing going on. I mean, I think now we see many organizations looking at applications for employees, for partners, and we're actually now starting to see more customer driven. Yeah, I just this morning talked to a large consumer technology company that is thinking about building a Gen AI app for their web-facing properties. So now I think we're getting much more into the next phase. But yeah, a year ago it was very much, to your point, James, really about building, planning, and thinking, and really trying to strategize around it. And one of the things that we see is that as companies are adopting AI, clearly more and more companies are. One of the big concerns is that they're not prepared to manage these risks. And this is from a study from Deloitte, a very recent study that you can look up. But organizations are not, 23% of them are not prepared to manage these risks. And when you think about the concerns, the number one concern is quality, reliability of outputs. But then the number two concern is really around how do you manage risks? And I think, as we talk to companies that are deploying AI, one thing that we are seeing is that the security teams, the risk and audit teams, the chief security officers are being asked, how do we manage this, and how do we think about managing these risks? And it is slowing down the adoption. And what we're here to talk about today is how you can increase that pace by driving security throughout the life cycle of your AI applications. And we're seeing an expansion of the attack surface due to AI for sure. And I think, when we talk to companies and customers that are rolling out Gen AI applications, a lot of their concerns are around data extraction and data loss, and whether that's intentional or unintentional, frankly. The model could behave in ways that it could communicate to the user of the model about whether it's PII, whether it's confidential data, whether it exposes things like the training data, either intentionally or unintentionally to that user. And so there's a lot of concern around that. And that does lead to a bit around how do you think about the content itself and moderating that content? Maybe there's some inappropriate content you don't want users to engage with. And so that also is a risk and an issue just around the behavior of the model. And then there's some more specific things that we're seeing. Probably the two that come up a lot, and if you look at things like the OWASP top 10 for LLMs, it highlights this, is that there's a risk around using techniques to break the guardrails of the model, jailbreak the model, and some of those techniques can be performed by doing things like prompt injection. And that can be done either directly through the AI application, or it can be done indirectly through things like files and images. And so there's real concerns and real risks around prompt injection. And then lastly, denial of service becomes a bigger and bigger issue, I think, as these applications get rolled out more broadly. Denial of service not only can impact the performance of the application for sure, it also can impact the cost. And I think we all know on this call that AI models and applications are not inexpensive to run. They require expensive hardware and compute, and denial of service could inadvertently or intentionally raise the costs to the end company that is hosting that model or application. And so, yeah, these are the things that we see that are very specific to the Gen AI landscape and the Gen AI models that all impact how customers think about this and how companies are thinking about this. And also really, again, highlighting the behavior that can be elicited by these models. And we're seeing some examples of this in the real world. So these are three examples that are fairly recent. I think a lot of people saw this example by Chevrolet around someone manipulating effectively a chatbot to get this person to be able to purchase a car for $1. I think this was pretty widely reported. And again, that was just through manipulations of the input to get a different output, which again is really about the behavior of the model and how that model can misbehave. Another example is Samsung engineers fed some sensitive data to ChatGPT, which created a variety of AI warnings through the workplace. And so this is really about training data and training the model in ways that is not intended. And then there's also impacts of reputation, right? Whether it's, again, confidential data, manipulation of the model, and then just reputation that one of your AI applications or chatbot misbehaves. And the Google example was a fair stark example of that. But James, do you want to talk a little bit about, we've been talking about some of these new risks, but how we think about cybersecurity controls that are more traditional and how they aren't sufficient in this case?
Right. So as you said, AI, and not just Gen AI, but AI, machine learning across the board, introduces a whole new class of threats. And what's missing are actual techniques to deal with these threats. The traditional controls aren't sufficient today. We've seen over the years since 2020 different threat frameworks grow up, like MITRE, Atlas, Cloud Security Alliance, NIST, OWASP, as you mentioned. They all sort of list their version of these different threat frameworks. The threats listed in these different frameworks can sort of be classified into two groups. One group that can actually be addressed with traditional controls, and one that requires new sort of AI specific controls. And I'll give you an example. In the MITRE Atlas, there's a threat listed in the framework on, keeping your physical access to your systems under lock and key. Well, yes, of course, as cybersecurity people, we know that if you gain access to physical systems, you're going to have trouble. Another example would be file scanning. Historically, we know If you consume any file into an organization, whether it's a PDF or an actual model file, those should be scanned for vulnerabilities. And those are very important. Would not discount any of the threats on these landscapes. What's unique to sort of the AI security space are the threats related specifically to the protecting the integrity of the behavior of those models. Things like data poisoning, model evasion, model extraction, denial of service, as you said, membership inference, all of these things are related to the behavior of the model and need specialized controls. So if you go to the next slide, I just want to give an overview of why AI and models, regardless of discipline, are susceptible to these new sorts of attacks. And I'm going to take a data science example. So as a data scientist, my discipline is to build models, and there's a proper way to actually build these models. You take your data and you carve out a portion of that data and you set it aside. I take the remainder of the data and I build my model. And then I go through a process of checking to see how well that model, how accurate it is on data that I've set aside. So the model has never seen that data, and I use that data to sort of evaluate the efficacy of the model. That's all well and good. The problem is when you deploy that model into the real world, you encounter edge cases. And in AI and machine learning, those edge cases are actually long-tailed, which means upwards of 50% of all occurrences that will present to that model once it's deployed into the real world are edge cases. And an edge case is actually an unpredictable event. It's basically a black swan. And it's very tempting for a data scientist, and I've done this in the past. I've built my model, I've deployed it into the environment. We get a complaint from a customer or a client, and they say it's not behaving well in this situation. And you're like, oh, that's an interesting situation. I'll gather more data, I'll build that into the model, and that black swan goes away. The problem is in the case of AI, there's still 50% of occurrences it's like having a flock of black swans. That's the inherent limitation of AI, and that is where the malicious actors like to play within that flock.
Excellent, James. Awesome explanation of this challenge for sure. Yeah, so I think before we go to the next piece of content, let's do another poll here. What are people's largest concerns around AI? All right, so we'll give people a few minutes a minute or so to answer this. All right, we have a few more folks answering, so we will give this another. Yeah, I think it's pretty much what we would think, James. Data privacy and data leaks is number one. We see this a lot, actually. And then we got a tie really after that around adversarial attacks and model manipulation. And then bias and discrimination, interestingly enough, actually didn't rank that high, James. It's kind of surprising, right?
It's interesting that model manipulation is sort of also an adversarial attack, so I can group those two together. Exploitation of vulnerabilities, I can get behind that because maybe it's, people are looking for specific vulnerabilities in the wild. But what's different with models, and we'll get to this, is that every single model actually has a bounds of competence. And you could say every model has its own unique vulnerabilities. So I think that could be a gap in between the data science and the cybersecurity.
Yeah, no, that's great, actually. Yeah, it's good. Thanks everybody for that. So let's talk a little bit about, to James's point about securing AI model behavior, right? And so, when we think about this, we think about it really both at build time, when we're building the model. James talked about this a bit. And then once that model's been built, we're going to deploy it as part of an application or as part of an application use case, and we need to protect that model at runtime. Because I think, as James said very clearly, that look, when we build our models and we test them, we're only going to be able to test certain bounds. before it gets put into the real world. Then we need some way to understand what those risks are and then monitor them at runtime. One without the other is very challenging to actually have a secure life cycle here. So let's talk a bit about how we think about this at build time. So I'll start here, and then James can give us a little bit more insight on this. But when we secure the AI model behavior at build time, we need to pen test the model. It's a little different than pen testing infrastructure or applications, web applications. It's definitely different than that because we actually need to test whether the model can be manipulated. And so to do that, we need to think about how do we send inputs to the model and measure those outputs, right? That is different if you think about it. Then I think James talked a little bit about traditional vulnerability exploitation, where you do things to the software to exploit that vulnerability and maybe gain access to that system. In this case, we're sending inputs to it, and we're trying to understand the outputs so that we can measure where those risks and flaws are going to be prior to deployment. And James, do you want to talk a little bit about this in a little more detail?
Yeah, so from the very beginning, we started in June of 2019. We had conviction that in order to protect your model, we need to be able to surface where the vulnerabilities and deficiencies are in each and every model, because every model, as I said, has these vulnerabilities or bounds of competence. And across your AI portfolio, you need to identify where the model is weak so that you can either take remediation action and monitor the inputs in when you deploy the model in real time. So you're monitoring the inputs for those inputs that you've identified could be an issue for your model. In the context of Gen AI, we take 3 different approaches. We can evaluate, or if you're looking to do this work, you should take sort of these 3 different approaches where you can take benchmark data of known issues and pen test, or in cybersecurity speak, you could say fuzz test your model against the static data set and check if the model is behaving or not. Using a version of actually perturbing your data incrementally, and this actually applies across all AI disciplines. You take inputs that you know the answers to, and you start to manipulate the data ever so slightly to see if you can get a different result or the model to misbehave. And finally, you can take a very sophisticated approach where you actually pit sort of one AI system against another, and that AI system is sort of performing its own red teaming assessment against the host model. So a combination of these 3 things can really surface where the model is weak, and that will inform the other important step of actually monitoring the inputs and outputs during production.
Excellent. Yeah, thanks, James, for that. Yeah, it's definitely a little different than traditional pen testing for sure, given the dynamic nature of these models, how they work, the scale and size of them. It's great. Good description there. So now let's talk a little bit about how we secure the model behavior at runtime. So, again, once we put that model into, once we've built that model, we've tested that model, we should have much more insight into kind of what the real risks are. But as James said earlier, there's always going to be differences at runtime, but we need to protect that and monitor it at runtime. And so from that perspective, we believe that securing the model behavior at runtime is critical, right? And there's really kind of a few ways that can be assessed here. One is to analyze the inputs and the outputs to mitigate various threats like prompt injection, jailbreaks, denial of service attacks, by looking at each of the prompts and analyzing those in real time. Okay. The other is to look at, threat monitoring to protect against, these new and evolving threats, things like, potentially malicious content as well as data leaks and PII. And to do this really well, we need to have some sort of rules engine that is using both deterministic kind of rules as well as stochastic rules. So that could be, like things that we all probably understand, things like regexes and block lists, but then we need to use it. We also need to look at more stochastic sets of rules using classifiers or LLMs. And a lot of that has to do with the fact that the context around these models is quite, is quite broad. It's not, this isn't like filtering IP traffic from one machine to another. It's much more contextual than that. And so using this rich set of traditional techniques as well as modern techniques allows us to secure this model behavior at runtime. James, do you want to talk a little bit more about the adversarial attack dynamic?
Sure. So this idea of pen testing to surface vulnerabilities, deficiencies, and then monitoring inputs and outputs during production, this applies across all AI disciplines, but Gen AI is even more fun because it's actually not an intelligent model at all. It's just this very large language model that has been trained on a vast amount of information. The developers of these models have done a very good job at sort of putting system prompts or meta prompts or guardrails around the model to sort of keep it on topic. The biggest limitation, in my opinion, is if anyone remembers your SQL injection attacks, we now, when we build software and we're dealing with data and databases, we use these frameworks to or frameworks best practices to always separate your command from your data. With Gen AI, your inputs, that all goes away. You have your command and your data all in one, and that is what gives malicious actors, both intentional or unintentional, the ability to, adversarially prompt a model to try to make it do things it shouldn't do, or maybe extract training data out of the model. The list of things that can, be manipulated is long, and that is why during runtime you need a very robust system that can detect and block on potential prompt injections. And the prompt injection could be both direct and indirect. It could be something that the user types in. If the LLM, and increasingly we're seeing sort of these agent systems where LLMs can talk to other LLMs, that LLM could go out to a web page and bring back content, but it actually contains an adversarial prompt within the content. Again, so it's sort of that command and the data being jammed together. The jailbreaking, knocking an LLM off of its rails so you can, have it behave however you want. The denial of service prompts, where you can imagine if you're an organization and you have, a chatbot exposed, someone could come along and confuse the LLM to, not stop generating content. So all of those tokens that are going by cost the organization money. Yeah, we could go on for quite a while on the interesting ways you can manipulate an LLM.
Yeah, absolutely. No, I think it highlights the real dynamic, James, on the behavior front. I mean, the other thing that we see is just a need to monitor this activity. So obviously, alerting, blocking, things like that are important, but you might just want to monitor it, right? And so companies can understand kind of what is happening and where they can hone in on protecting against certain behavior. So that's another kind of byproduct of these approaches as well. All right, so we've got another poll here we want to push around which of these AI safety measures are you currently using? All right, we've got some answers coming in. They're not surprising to us, I don't think, James, but so James, what would you guess the answer to neither is? Because so the answers are AI pen testing, an AI protection layer, firewall, both or neither. What do you think?
What do I think the highest?
Yeah, what's the highest? What would you predict it to be?
I'm guessing neither.
Right. Yes, it is. I'll share those results. Yeah, so 78% of you said neither pen testing or firewall. 13% said both, which is awesome. I think we're seeing, I mean, look, we were talking earlier about the adoption of Gen AI in businesses, and it's definitely growing and evolving for sure. I think and in 2024, people are definitely rolling out, applications. It's not surprising that not everyone has a security solution in place, and it's effectively what we see a lot when we talk to customers and people in the market. So it makes total sense, actually. And so let's talk about how we can help you with that. So this is a case study of one of our customers that is using our platform to protect their AI models and applications. This company has got hundreds of models actually in production that they're testing those models for weaknesses and flaws, as James talked about. And they are also protecting those models at runtime. I think the challenge that this company had was that as they were rolling out AI applications, they were absolutely trying to figure out how they were going to protect them, and that the existing kind of cybersecurity solutions, as we discussed earlier, obviously help you with a lot of areas and potentially some aspects of AI, but doesn't help you really managing that behavior. This company was very concerned about the behavior of the models and was aggressively rolling out applications based on those models. So we were able to help them find those flaws and vulnerabilities during build time, and then protect them at runtime in a very scalable, extensible way. And so, yeah, we continue to work with this company very closely, as we do with all of our other customers. So it's a good example of kind of what we had seen and what we've been talking about. And really, our platform that we built here at Trojan AI is purpose-built to solve this problem around helping customers deploy AI securely, focused on securing the behavior of the model. Again, really understanding the inputs and the outputs and how they can be problematic and cause risks and vulnerabilities. We have a product that tests models during build time. Our product's called Trojan AI Detect, and it automatically pen tests models by making inference to those models and sending those inputs to those models and measuring the outputs with a series of out-of-the-box tests, as well as the ability to customize those. And then we've got a product called Trojan AI Defend, which is sometimes people refer to this as a firewall-like product that monitors and protects applications and models in real time. So we effectively sit in between the application and the model and analyze each prompt going to and from the model, and can apply policies to that for things like PII, jailbreaking, prompt injection, denial of service. Bringing these two things together does allow us to get better context, because as James talked about, that these models have very large sets of data, and really understanding those use cases by both testing and protecting allows us to provide a comprehensive solution around securing the behavior of the model to a customer. Yeah, you can find out more at our website, obviously, as well as you can, there's been a variety of reports in places like Gartner as well on this problem area, as well as Trojan AI. And so just to kind of wrap up, from a standpoint of kind of what we talked about today, that, hey, look, the Gen AI era is here. It is happening. Businesses are adopting AI fairly rapidly, and it's introducing a new threat landscape. And that threat landscape really does involve understanding the behavior of the model. And that, look, we had that poll that showed that many organizations are not prepared for the risks that AI presents. And so new technologies and new approaches are needed to really understand this, and securing that behavior of that model, both at build time and runtime, is a way to really make some real progress in your confidence and your ability to roll out AI securely. We got some great perspective from James on that as well. So with that, I think we're going to open it up to questions, and we do have a bunch of questions, James, actually. So let me just look through these. Let me find it. Okay, so here's a question, James. A little tricky. You and I were actually talking about this morning a little bit. So what's a performance metric that you look for to see how, when you're pen testing an AI model, that it's performing to your expectations?
Isn't that the crux of everything?
Yeah, it's a good
So
question. We were just talking about this actually.
I'm gonna answer this first for predictive AI, your traditional AI.
Yep.
That's more clear because you typically have data and you know the ground truth. So you can run adversarial attacks, do your pen testing, and you can actually see when you've flipped a classification. In Gen AI, you're just sort of changing the responses. It's very difficult and it's very tempting for vendors to come up with benchmarks, and you'll hear vendors say, hey, ours is 98% accurate. First, I would lay caution on a single digit accuracy metric is not acceptable. You always need to look for, like, double click into that. It's like if you're looking for a particular item or a particular behavior, and I classify everything as that behavior, I could say I'm 100% accurate, couldn't I? But what are my false positives looking like? So you need to separate out into precision and recall sort of metrics. And happy to share more after this webinar. The other thing is, remember when we actually use data to build the model. Often it's, again, tempting if I'm building a model and then I'm going to take a set of data to benchmark my accuracy, how well my model behaves on that data, even if I do it correctly and the model has not seen the holdout data set, that entire data set comes from the same distribution of data. There are so many distributions of data. So a benchmark has inherent limitations. That said, we still have to provide benchmarks. We have to be able to, state in these cases, on use cases that look like this is the sort of accuracy, aka precision and recall, that you can expect.
Yeah.
Where the rubber meets the road, though, is in production. When we actually deploy it into an enterprise environment, how does it behave in that environment? That's the true measure.
Yeah, no, I think it's great. I think the other point, James, too, is that this is also why you need to couple testing and protection, because you can't test for every use case. And in protecting the model and the behavior of the model, you're able to catch other things. So I think it's a really good point. And to that point, there's another question in here. You and I can both tackle this because it's a really good question about this question effectively gets to monitoring and rule-based protection could be very costly if you wind up using things like LLMs as judges or moderators to protect against these threats. And so I'll take a little bit of a stab at this, James, and then you can get into it. But what we see is that there's a need for, if you want to monitor and protect behavior at runtime, there's a need to do this in a multifaceted way, right? So, and we outlined this earlier, that we need both deterministic rules and stochastic rules. Deterministic rules can be used fairly simple things and can be effective for certain types of content and are very inexpensive to run and can be, like I said, very effective. But you need to couple that with stochastic rules that might use machine learning classifiers, they might use named entity recognition models, or they might use LLMs. And LLMs do cost money to run. I think what we're starting to see is that there's an opportunity to use smaller language models for specific types of content. So I think what we would say, James, is like a mix of these can create both good accuracy, performance, as well as cost optimization. Is that, James,
Yeah.
anything to add to that?
Yeah, I would agree to that. Having, the chain of checks that you're going through and short circuiting once you've, decided you're going to block on something. And you're right. So for our LLM moderator, which we call TrojGuard, we are, you know, constantly evaluating how good it is versus how big it is and how much does it cost. Um, that's really, the ongoing challenge, and we believe we've struck a really good balance with TrojGuard. It's currently got 16 classes. It's it's small enough it can deploy to, a very cost efficient architecture or environment. And yeah, we're always pushing the needle on sort of how we can ensemble models together, different types of models, different size models, while keeping the accuracy in acceptable bounds.
Yeah, yeah, that's good. James, another question just came in about, and you hit this earlier, but maybe you can clarify. Is the Trojan AI platform for just Gen AI?
No, in fact, we're an AI security company, so we've been, building protection since 2019, and to us, Gen AI is just another AI discipline, and yeah, we're sort of multifaceted that way.
Yeah, yeah, we support NLP and Tabular as well, for sure. Uh, Here's a question, I'll handle it a bit. Um, how do you deploy these solutions on-prem or SaaS? Is there an advantage or disadvantage? So this is a great question. Our take is that this data is very, very sensitive to companies, and that the other thing is that the performance is very important for these applications that companies are building. And so, we believe that deploying this in a customer's environment is ideal for a couple of reasons. One is the latency, especially at the protection layer, is obviously lower because it doesn't have to make a round trip to a third-party service. The other really big thing is that the data itself and the prompts themselves can be all contained in a customer environment, and a third party doesn't need to see those prompts. And so, for us, we deploy our product in a customer's environment. Usually, companies deploy it in their own cloud tenants, but we don't. It doesn't really matter to us very much. So yeah, the advantage really to on-prem is privacy, security, potentially performance impacts. The SaaS piece would just you'd have to make a round trip to that service quite frequently, and there would also be potential security concerns with that as well, or at least privacy concerns, I should say. All right, James, here's a question for you. Is there a difference between AI red teaming and AI pen testing? You like this one?
This is an awesome question because I don't think the space has figured it out. In AI security, in my opinion, we are misusing the term AI red teaming. Um, Lee will tell you that I have this argument quite often. To me, red teaming is a process. It's doesn't, have any bounds on what you do to red team. You throw everything at a system, and there's a process. To do that, you use pen testing tools. I happen to think that we provide pen testing tools. Now, in some of our material, you may see us, reference AI red teaming. And that's only because there's an expectation. Some people are expecting us to say the words AI red teaming.
Yeah, no, that's right. That sounds good. Okay, here's another question. This is an interesting one. I have some opinions on it. You probably do too, James. The question is, back in the day, we had snort and public lists of attack signatures. What can or can't be done this way with natural language attacks? Right, so snort, open source IDS, very, very successful. Um, and yeah, there was an open source set of attack signatures it would look at from a network standpoint. I think with natural language attacks, what I would say is that we're at the kind of the beginning of trying to understand the bounds of those, right? Clearly, malicious URLs in these kinds of environments should be filtered, can be filtered. That's something that can be done today and needs to be done and updated and monitored. I think the other thing we'll see, I think, is that as models evolve and as models are tested more in the real world, we will find a set of injection attacks that probably, like any other vulnerability, will be disclosed. We've seen some of those actually for some, not for some of the bigger models, but some of the smaller ones, and those will need to be covered as well. So I think there is an opportunity to kind of have a set of attack signatures that are continually updated as well. James, anything else on that?
No, I would agree. In the case of Gen AI specifically, um, it's not just looking at a single individual prompt, but it's sort of monitoring the alignment of a conversation. And there's several attacks that have been identified and actually given names,
Yeah.
like a crescendo attack where someone gently tries to take the LLM out of alignment. So those sort of techniques, as they're surfaced, will be included in the protection libraries.
Yeah, no, that's right, James. Awesome. All right, we're going to take one more question here because we're running out of time. All right, the one last question. Okay, this is a pretty good one. Are there any performance concerns when using these kinds of solutions? Well, the answer is definitely something that needs to be monitored and managed. I think clearly, especially at runtime, we want to make sure whatever solution we use has acceptable latency levels, right? These kind of solutions do require analytics to be applied. And we talked a little bit about that. One aspect of that could be, and we were talking more about the cost effect earlier, but the performance effect is also very real. So yeah, I think having a system that, especially systems, and we would tell you they need to be in line, need to be able to scale, meet the performance needs of, millions of tokens at a very rapid rate. And so performance concerns are real. And I think that's why, for at least for us, we focus on having kind of a chain of protections that can allow us to perform at a high level while meeting the accuracy and effectiveness requirements. James, anything else there?
Yeah, I would add to that there's different approaches you can look at. Um, some favor an API approach,
Yeah.
whereas we favor an actual web application firewall where we centralize all of the traffic through. And as long as that piece has been done correctly, it can run very performant, it can be very scalable, and it can support, as many use cases as you want to throw at it and scale up your compute as you go. The other benefit to having a centralized um, web application firewall or reverse proxy is it centralizes the security function to cybersecurity folks. You don't have to rely on your application developers to implement the API calls correctly and consistently across the board. It is all done for you. And again, you're probably looking for that firewall piece to be written in something really fast like Go. So it minimizes the performance overhead.
Yep, exactly. Excellent. Well, thanks everybody for joining. We appreciate the time, and the questions were great. And thanks for your participation in the polls. And have a good rest of your day. We'll see you next time.